Hi everyone. So today we will discuss the level order traversal. So in my previous videos, what I have discussed about the DFS traversal techniques. As part of the traversal technique, we have three different algorithms. You can say pre-order, post-order, and the in-order. So I would highly recommend please check out those videos as well. Now this is the BFS breadth first search traversal technique. In this technique, we will do the traversing level by level. In case of DFS, we used to go in one path up to the last, and while coming back, we will find the new path. This is how that approach will work. But BFS, it will work level by level. Okay, so let me explain you for this tree. So here in this tree, let's say you want to do the level order traversal. Traversal means you want to print every node of the tree. How we can do that? So you will start from the level number one. You will say, hey, what are the nodes at the level number one? So we have just one, just print it. Now you will go towards child of the one. There are two nodes at the level number two, node number two and node number three. Let us print them. So you will get two and three. Now you will go towards third level and you can see here there are four nodes which are at the level number three. So you will just print them 4, 5, 6, and 7. So this is how we are doing that. Now, how we can solve this problem? Because here what we are just doing the things like we are traversing, and if we are at the level number one, we will print all the node of the level number one. Once we are done with this part, we will go towards level number two. We will print all the nodes which are at the level number two. Next, we will go towards left. So next level, at the level number three, what all nodes we need to print, we can do that. Now, I think if you have watched my previous video, in that I have discussed about the how to print nodes at the given level. Okay, so I would suggest please check out that video first. Click on the I button, you will get it. So in that video, what we have discussed, in that method, you just need to pass which level node you want. Okay, so you will pass the one, you will get one. You will pass the two, you will get two and three. If you will pass three, you will get 4, 5, 6, and 7. Right? So don't you think we can use the same approach here? Yes, absolutely we can use. Now how to do that? One second. So here in that approach, what we will do, first of all, we will get how many levels our tree has. Okay, now to find out the number of levels, we can use the concept of the height of the binary tree, which also there is video I have uploaded for the height of the binary tree. So now I think you will understand why I am uploading the video in this way. Because when I was planning to upload video on this level order traversal, then I think, hey, these two things people should know before coming to this question. That's why my previous two videos are height of the binary tree and the how to print nodes at the given level. So I will always try that you will understand the thing one by one, and it will make the things very easy for you if you will follow my series in the proper way. Okay, so we know how to print nodes at the particular level. We know how to find how many levels our tree has. So we can simply run a loop. Once we know how many levels we have, just run a loop for these many levels and print the nodes at the each level one by one. Right? Now, so let me explain you with the help of code. Do not worry about that. So here, this is the code which we have discussed. How to get the height. It will give me the how many levels our tree has. Next, we have discussed how to print nodes at the particular level. Now, the same concept I will use just to, just to print the level order traversal of the tree. How to do that? So first of all, you will get level. Level will give you the height. Okay, just call the height method. Now, once we got the number of levels we have, just run the loop from I1 to level number of levels we have, and you just need to call the method. Let me just type paste it here. All right. What you will pass here, you will pass the root node, or you will always start from 1 and you will pass the node on for which you want to print the data. So let me just quickly call it. Okay. See, we got one level 1 node, level 2 are 2 and 3, level 3 are 4, 5, 6, 7, level 4 is 8, right? How we can use these two things just to print the level order traversal of the binary tree. Now, what is the problem with this approach? The problem is nothing but it will take more time. Why? Because first of all, we are traversing the tree just to get the height of the tree, right? That is the one traversal we are doing. Now for each level, okay, for each level, we are traversing the tree just to get the nodes at the particular level. So we are traversing the tree 2 times here, okay? And for each level we are traversing. So it will be time complexity will be level number of levels multiply with the O of n, which are the number of nodes in the tree. So if you will see, it will be in the worst case, time complexity will be O of n square, okay, when the tree will be skewed tree. So if you don't know about skewed tree, it's very simple. The tree in which all the nodes are in the left side either, or all the nodes which are in the right side from top to bottom. That tree is known as the skewed tree. Now space complexity is nothing but we are not using any extra memory, but we are calling the recursive calls every time. So in the worst case, we will have n number of nodes in the stack if the tree is skewed tree. All right. Now we can improve this approach because this is very costly operation. We are using the two loops here just to print the level order traversal. Now we can improve this with the help of queue data structure. Now, what is the logic which we can use just to improve this thing? So here, what you need to do is, first of all, let us take one queue, and in that queue, you just need to insert the root node. Okay, so you just need to insert the root node in the tree, in the queue, and just run a loop unless until your queue is not empty. Okay, inside that loop, what you need to do, you need to delete the first element of the queue. Once you will delete the first element of the queue, after that you need to do two things with that deleted node. First of all, you need to print it. Second thing is you need to check if that deleted node has left child and the right child. If that node has, you need to insert these two, left child and right child, into the queue again. All right, that is the simple concept. Now let me explain you with the help of example. If do not worry about, okay, it's very simple. So what I was talking about is, let's say here this is the our root node. Okay, now what I told you, first of all, we'll insert the root node into the queue, okay, which is node number 1. Now what we will do, we will run a loop until our queue is empty. So our queue is not empty because queue has 1. Now just delete the data from the queue. So you will delete it and you will do two things here. First of all, you will print it, and after print, you will check if this deleted node, which is 1, has left child and the right child. If yes, insert those two into the queue. So left of 1 is 2, which is not null. I will insert into the queue, and right of 1 is 3. So you will insert these 2 and 3 into the queue again. Not again, first time. Okay. Now, after that, what you will do? You will do the same thing. You will check, hey, queue is empty. No, it's not. Just delete the first element of the queue. This time you will delete 2. After deleting the queue, you will print the deleted node data, which is node number 2. All right. Once it is done, what you will do? You will check two things. Does this node has left child and right child? If yes, insert into the queue. So 2 has left and right both. So you will insert left, then you will insert 4 into the queue. Once these are done, what we will do, we'll delete the next node, which is 3. So once you will delete the node number 3, you will insert the 3, you will print it first of all. And after print, you will insert the left and right of 3 into the queue. So you will get 6 and then you will get 7. All right. Now what you will do, again you will check, hey, queue is empty or not. It's not. You will delete the 4 from the queue. You will print it. After print, what you will check, does 4 has left and right child? No. So do not insert left and right of the 4. Again delete 5. You will print it. After deletion, you will check left hand child. No, they are not there. So move to the next node, delete 6 from the queue. You will delete 6 here, and you will check left and right of 6. They both are not there. So move to the next node. Now you will delete 7 from the queue. You will print it first of all, and after print, you will check left and right of 7, which are not there. So it means we are done. Why we are done? Because queue is empty now. We will come out of the loop, and you will see here, we have printed the level order traversal of the tree, which is nothing but 1, 2, 3, 4, 5, 6, 7. All right. So this is the simple logic. So very simple, start from the root node, insert into the queue, run a loop until queue is empty, and delete the first element of the queue. After delete, print the data and insert the left and right child of that node into the queue if they are not null. So let me quickly explain the code. Okay, it's very simple. Now we have discussed about this approach. This approach was taking off n square. Let me comment out this one. I want to show you the level order traversal of the queue with the help of queue. So here what you need to pass, just pass the root node. All right, now let me run it. You see we are getting 1, 2, 3, then level 3, 4, 5, 6, 7, level 4 is 8. How we are doing that? So first of all, this is the very important condition you can apply. Here, if you will not apply also, it can break, yeah, because you are inserting without checking null. So it will cause the issue. So this is very important again. Now you will declare a queue. You will insert the root node into the queue. You will run a loop until your queue is empty. Now you will delete the node from first. It will delete the first node of the queue. Okay, this is the Java. So Java method just delete the first node of the queue. Once we got that, we will just print it. This is the first part which we have done. Now second part is check for the left and right child of the node, and if that is not null, you need to insert into the queue. So similarly we have done for the right child also. All right, so that's how we can do the level order traversal of the binary tree with the help of queue data structure. Now here time complexity will be nothing but O of n, because we are just traversing each node only once. Yeah, but the next thing is we are using here extra memory, which is nothing but our queue. So time complexity will be of n, and space complexity will also be of n this time. All right, so I hope it is clear. And if you feel something is not clear, feel free to comment out. I will cover those doubts in my next video. And if you like my content, everyone, please like, share, subscribe. Thank you. Enjoy, everyone.